Hi, everybody. Welcome to lesson 17 on slope. So we're in the middle of our third unit right now. So far, we've done lesson 15, which was our introduction to graphing. And then most recently was lesson 16 on functions, domain, and range. And now this lesson on slope is kind of getting back to how the unit started. We'll be plotting points, graphing lines, but also talking about the slope of lines. So let's take a look at the first thing we have here, which is a formula. Slope is often represented with the letter M. My understanding is that comes from the French word monter, which I believe is spelled M-O-N-T-E-R, which means to climb. So for years I wondered, why do we use M for slope? But not everything is in English, so just a little tidbit for you, to climb. So M is for slope. All right, the formula basically goes like this. It's the change in y coordinates, or vertical change of your line, over the change in x coordinates, or the horizontal change. So slope is a ratio. It's a comparison between vertical change and horizontal change. Sometimes the phrasing that we use is rise over run. So I'm going to write that down, rise over run. And when I say over, we are talking about a fraction here, a ratio. And then the official formula for M for slope is over here, y2 minus y1 over x2 minus x1. The 2's and the 1's are called subscripts. They're just little labels for x and y coordinates. So with lines, there's almost this pattern of the relationship between any 2 points on the line. So it doesn't matter which 2 points you choose to find the slope, because no matter where you are on the line, the slope will be constant throughout. That's not the case for other types of graphs or functions, but that's a lesson for another day. So we're dealing with lines. So here's our example. We'll use the formula, and we'll also take a look at the graph and kind of compare those things. So it says, find the slope of the line that passes through 3, 6, and 1, 2. So 3, 6, and 1, 2 are both ordered pairs. They're points on a line. What we can do is label them with x and y. So I'm going to write x under the 3 and y under the 6, and then x under the 1 and y under the 2. So I can't have 2 x's and 2 y's. That doesn't quite make sense, and that's why we need these little labels or subscripts. So I'll just add to this and write x1, y1 for my first point. We'll just call that point number 1, and then x2, y2 for point number 2. So again, these are not exponents, they're just labels or subscripts. Okay, so here's our formula. M, or slope, equals y2 minus y1 over x2 minus x1. So the y2 minus y1, that's our vertical change. It's the difference or change in the y coordinates. And then the x2 minus x1, that's the difference or change in the x coordinates. And the larger answer that we get for our slope, the steeper the line is. Okay, so let's plug in y2 minus y1. So based on our labeling here, y2 is 2 minus, and then y1 is 6. So I'm writing 2 minus 6 for the numerator of my fraction or my ratio here. And then the denominator, x2 minus x1, that's going to be 1 minus 3. In case you're wondering if it matters which point I label x1, y1 and which point I label x2, y2, it doesn't matter as long as the 1's go together and the 2's go together. Your work in the middle of the problem might look different from mine, but our final answers should come out to be the same. So let's simplify. 2 minus 6, that's negative 4 in the numerator, over, and then 1 minus 3, that's negative 2 in the denominator. Negative 4 over negative 2. That reduces to positive, negative divided by negative is positive, 2 over 1, or just 2. So our answer, find the slope of the line. The answer is 2, or m equals 2. Thinking of it as 2 over 1 can be helpful, especially when we're making a graph. However, if we're asked to give the slope for our final answer, we can't give it over 1 that's not considered simplified. So 2 over 1 would not be an acceptable answer. 2 would be the final answer. Okay, but knowing that the answer is 2, I am going to go back to this 2 over 1 for a moment here, because we do want to recognize that slope is comparing two things, right? So for every 2 units in vertical change, or for every 2 units of rise going up, there's 1 unit of horizontal change, or run, in the line. Okay, so looking at the line that's graphed, notice the points. There's 1, 2, and then there's 3, 6. Those are the same points we just plugged into our formula. So I'd like you to notice the relationship here, and we're going to actually count rise over run. So here's another way to find slope. First of all, read your line from left to right. So that's the first tip that I'm going to give us. Most of us are used to reading left to right. English is read that way, and many other languages as well. So I think this is something that's familiar to most of us right now, reading from left to right. So that's how we're going to read our line as well. So starting at this point, 1, 2, let's count our vertical change. So we're going up, 1, 2, 3, 4, and then over 1, 2. So up, 4, over 2. 4 over 2, there we are back to our answer of just 2 over 1, or positive 2. So that's another way to find our slope. We can simply count rise over run on our line. Now when we did our formula, -4 over -2, that was kind of going in the opposite direction. That's going from right to left. I'm not going to show you that because I think it will be too confusing. I think staying left to right is a good consistent way to go if you're doing this from a graph. So finding slope from a graph, read from left to right. Notice our line is going up from left to right, so we have a positive slope. Now, if you think of the slope as 2 over 1, here's another way to think about it. You could go up 2 over 1, and we still land on the line. Up 2 over 1, and you could continue up 2 over 1. So this becomes a nice, I think, easier way to graph. Once you know the slope of a line, you can easily graph many points without plugging in over and over and over. Once you know the slope, all you need is 1 point, and then the slope will kind of carry you on as far as you want to go. Up 2 over 1 in this case. All right. So let's do another example using the formula. The next example says, find the slope of the line containing the following 2 points, -2, -3, and -2, -5. So let's label our coordinates, x1, y1, x2, y2. We'll plug into the formula. We don't have a graph to look at right now, although we could sketch these points, and maybe we will do that. Let's just use the formula first. So m equals y2 minus y1 over x2 minus x1. Based on our labeling up here, we're going to carefully plug in. Now pay attention to all the different negatives and the minus signs in the formula. Be careful. Okay, so y2, that's -5, minus, and then y1 is -3. So I'm writing -5 minus -3. Notice I did not write -5 minus 3. That's different. Okay, so we need the minus sign from the formula, and also y1 happens to be a -3. So again, just be careful with your signs. Same thing's gonna happen down here with the x's. x2 minus x1, that's -2 minus parentheses -2. Now let's simplify. -5 minus -3 really becomes -5 plus 3, which is -2 in the numerator. -2 minus -2 becomes -2 plus 2 in the denominator, which is 0. So it looks like we're getting -2 over 0. This is not a real number. We cannot divide by 0. So the answer is actually undefined. So there are some lines that have a slope that is not defined or undefined. Let's do a little sketch of what this line would look like so we can know when to expect this answer. If we were to plot these 2 points, first of all, notice that they both had the same x-coordinate, right? They both had that -2 x-coordinate. So -2. One of the points was -2, -3, 1, 2, 3. And then the next one was -2, -5. Okay, not my best graph, but you get the idea. If you connect these points, you'll see this line goes straight up and down. It is a vertical line. Okay, and the equation of this line is actually just x equals -2. So all vertical lines up and down always have a slope that is undefined. And you'll know if it's undefined if you're trying to divide by 0, if you have 0 in the denominator. Now, in case you're wondering, if you had 0 in the numerator instead, different situation, if m equals, let's say you had 0/6 or something, that would be a slope of 0, okay? That would be a horizontal line. So vertical lines going up and down, those are the ones that have undefined slope, whereas horizontal lines going side to side, those are the ones that have 0 slope. People tend to get those two things mixed up. It kind of feels like 0 is undefined, but it's not. 0 on the top, that's 0, whereas dividing by 0 is not possible, that's undefined. And if you try that on your calculator, -2 divided by 0, you'd probably get an error message that says domain error or something like that, and that's your clue that the answer is undefined. Okay, and that brings us to our next conversation, which is there's really 4 types of slope. Okay, the 4 types are positive, negative, 0, or undefined. Okay, so we kind of just went over a couple of these, but let's just make sure we have the complete picture. So again, reading your line from left to right, this red line, the one that's going up from left to right, this has a positive slope. Okay, so sometimes I draw a little stick figure on the bottom and ask which way is he going? Going up from left to right. This blue line is going down from left to right. My stick figures need a little work here, that's okay. Which way is Mr. Stick Figure going? Down. Okay, so reading from left to right, if you're going up, that's a positive slope. If you're going down, that's negative slope. Most lines are one of these two things, either going up or going down. Positive or negative. But here are the other 2 types. Horizontal lines going side to side, those are the ones that have a slope of 0. Okay, so here's an example. The equation is y equals 2. If I pick 2 points on here, it doesn't matter which 2 points I pick. You can see we're going up nothing, up 0 and then maybe over 3. So again, you get that fraction, 0 over something is just 0. So in this case, maybe I'd say the slope is 0 over 3 or 0 over 5 or 0 over, it doesn't matter. The answer is going to be 0. So a horizontal or side to side line has a slope that is 0. And then a vertical line going up and down, this is the kind that has a slope that is undefined. And if you want to count it, pick 2 points on the line. Maybe you'd say you're going up 2 over 0. There's that fraction over 0, can't do that. So that's going to be undefined. Okay, so the 4 types again, going up from left to right is positive, going down from left to right is negative, just sort of a flat line, that's 0. Okay, so if I were to draw my little stick figure guy on the horizontal line, just there, he's not going up or down, he's just kind of having a boring flat walk. And then finally, the up and down line, the vertical line, the slope is undefined. Maybe that person's just falling off the cliff. There you go. Anyway, okay, so positive, negative, 0, undefined are 4 different kinds of slope. All right, so next examples, we're finding the slope from a graph. I've kind of already showed you this a little bit. So I'm going to show you by counting from left to right. We're going to pick 2 points and count rise over run. This works well if you have 2 points that are already labeled for you on your graph. All right, good. So you can see our first line, it is going down from left to right. So we should already expect that we're going to have a negative slope here. Because again, reading it from left to right, the line is going down. Let's count how far it's going. And this is going to involve essentially drawing a triangle on your graph. Okay, so I'm starting at this point over here. And then I'm going to count down 1, 2, 3, 4. So I just counted down 4 and then over 1, 2, 3, 4, 5, 6, 7, 8. Over 8. So down 4, that means I'm writing -4 over 8. Now I'm getting a fraction. I should reduce by dividing by a common factor of 4 here. So my final answer here would be -1 over 2, or -1/2. Okay, another option is if you don't feel comfortable counting like this, you can find the coordinates of those 2 points and use the formula. Okay, so the first point that I found was -4, 3. The second point was, let's see, that's 4, -1. So you could plug in and it would look like this. -1 minus 3 over 4 minus -4. There's your -4 over 8, which again reduces to -1/2. So use whichever method you prefer. I think it can be nice and quick to do it just by counting on the graph. So give that a try if you haven't already. But the formula is there for you as well. All right, our next example is a graph that looks like it is going up from left to right. So this one will have a positive slope. All right, and let's count. Starting from left to right, I'm going to count my rise over run. So I'm counting up 1, 2, 3, 4, 5. So I stop when I'm kind of level with that next point. So I went up 5, and now I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. Over 8. So my slope would be 5 over 8. And it is positive because we're going up from left to right. Once again, I could use the formula. Now this graph is not labeled as nicely, but each unit is one space. So 1, 2, 3, 4, 1, 2. So it looks like our points are -4, -2, and 1, 2, 3, 4, 3. Okay, so here's what the formula would look like. 3 minus -2 over 4 minus -4. So it would be, there's that 5 over 8. So again, choices for how to do this. You can use the formula, but if you're given a graph, I would recommend that you try just kind of counting rise over run. Okay, so there's an example of negative slope as well as positive slope. I think next we're going to see the other 2 kinds. Okay, so our next example, this is the one that has this blue line here. This is a horizontal line. You may remember what we said already about horizontal lines. So we can go back and kind of check that a couple slides back. Horizontal line, that's the one that was flat. We should expect a slope of 0. So if you remember that, just fill it in and move on. No need to really show any work if you just remember that horizontal lines have a slope of 0. Or if you plug in, here's what your formula would look like. x1, y1, x2, y2. -1 minus -1 over 5 minus -1. That would be 0 over 6, which is 0. Or if I were to count rise over run, I'm going up nothing. And then over, let's see, 1, 2, 3, 4, 5, 6. So over 6. So there's kind of almost 3 ways to do that. One is just to memorize that horizontal lines have a slope of 0. The second option is to plug into the formula. And then the third option is just to count that rise over run. So the slope is 0. Okay, and then our last example in this little set of graphs, we have a vertical line going up and down. This is the one where the slope is undefined. So you get to choose that choice B in this homework example. Sometimes you'll see the phrase not defined. The slope is not defined. Rather than the word undefined, those are the same thing. Okay. Now there's no points labeled on this graph, so you could pick 2 and count rise over run. Maybe I'll pick this one. What is that? 4, 0, and then maybe this one, 4, 3. I'm going up 3 over 0. So 3 over 0 would be undefined. Okay, or if I were to use the formula, again, I would end up with some fraction that's over 0, and then I'd still have to say the answer is undefined. All right, so we just saw, just backing up a little bit, we saw an example of negative slope going down from left to right, positive slope going up from left to right, 0 slope, that's this horizontal line, this flat line, and then undefined slope, that's the vertical line going up and down. Okay, good. So the last thing we're going to see here is we'll see this equation of a line, this one way of writing the equation of a line called slope-intercept form. And then we'll see a couple of applications, I believe. All right, so what you're looking at now, y equals mx plus b. This is called slope-intercept form. M stands for slope, we know that. B, I don't have a reason for you, I didn't look this up. B stands for the y-intercept of your line. This will be extremely helpful in many different types of problems going forward. If you have one point and a slope, you're good to make a graph, okay? So this will be extremely useful if you can get an equation in this form, slope-intercept form, because you'll have a y-intercept and then you'll be able to use the slope to make your graph from there. So here's our example. It's just an algebra question. We're not making a graph right now. Write the following equation in slope-intercept form. So we're essentially needing to solve for y. We want it to look like this, y equals mx plus b. Our equation is 6x minus 5y equals 10. So we're going to get y by itself. We've done this before. We'll subtract 6x on both sides. So that's negative 5y equals negative 6x plus 10. I am going to encourage you to put it in order now, okay? So let's make it match this slope-intercept form. Leaving it as 10 minus 6x, now it's kind of out of order. It will be harder to tell the slope. And that's probably the next thing we'll be asked for. Okay, so I subtracted 6x on both sides. 10 minus 6x, I rewrote it as negative 6x plus 10. We still have negative 5y. So our next step will be to divide everything by negative 5. And that's all 3 terms, and we'll simplify if possible. Okay, so the negative 5's cancel out, y equals negative 6 over negative 5. That just reduces to positive 6 over 5. So I'm writing positive 6 over 5x, and then 10 divided by negative 5 is negative 2. So I'm writing minus 2. You could also write plus negative 2 if you want. So here's what this now tells us. We now know our y-intercept is the point 0, negative 2, and that's coming from this b value over here, y equals mx plus b. It says minus 2, so that means our b is negative. So our y-intercept is 0, negative 2. Our slope is positive 6 over 5. There we go. Okay, so that's m, that's your slope, 6/5, and then your y-intercept is 0, negative 2. So if you were to make a graph, all you would need to do is start at 0, negative 2, and then you could use the slope to make your graph. You could count up 6 over 5 to the right and plot your second point. Okay, and there's not even any extra table you need to fill out for all those extra points. You don't even need to really worry about plugging in numbers for x here. So once you know the slope, you kind of have almost an easier way to make your graphs. All right, so there's one more application. problem that we're going to look at, or two more, excuse me. I took these straight from the homework. So let's take a look. All right, slope application. So number 1 says, find the slope or grade of the treadmill. Give the answer as a percent. So slope has to do with steepness. So there's different applications of this. One example is using the word pitch for the steepness of a roof on a house. In this case, grade, that's sometimes used to describe things that involve ramps, like a treadmill or a handicap ramp or something like that. And the steepness of those things definitely matters for safety reasons. So we need to know the slope or grade of the treadmill. So what's labeled here kind of looks like a little triangle. There's the height of this triangle, that's 0.5 feet. And then this width or base of the triangle, that's 5 feet. So that's kind of like rise over run. Okay, so there's no X and Y coordinates here. There's no formula exactly other than rise over run. I guess that is a formula. I just meant there's no ordered pairs. Okay, so the rise, that's this up and down, this vertical distance, the 0.5. So 0.5 over. And then the run, that's the 5. So 0.5 over 5. You can use your calculator, just divide this. We're getting 0.1. So that's kind of unusual to have a decimal answer, but it is one way to talk about steepness. In this case, we want the answer as a percent. So just a quick little reminder about percent. To change a decimal to a percent, what you want to do is just multiply by 100, or you might just remember about moving the decimal place twice to the right. Okay, so percent just means per 100. Okay, so 0.1 as a percent, if we move the decimal twice to the right, we're getting 10, or 10%. So one way to think about this is the rise, the vertical change over here, is 10% of the run. So maybe for every, how do we say that? For every 100 units of horizontal distance, there's 10 units of vertical distance, something like that. Okay, so we could say that the slope is 1 over 10 for 1/10, but that's not what we're asked. We're asked to give it as a percent, so we'll just leave it like that. So we divided, rise over run, we got a decimal, and we changed it to a percent. So we would say this treadmill has a grade or a slope of 10%. That's a little different from the graphs we saw. Okay, and then our second example has to do with rate of change, which is really what slope is. Okay, slope is rate of change. It's the comparison of changing in y coordinates versus changing in x coordinates. In this case, the graph is labeled with some units. So on the left side, on this sort of y-axis, it says value of computer in hundreds of dollars. Okay, so hundreds of dollars is our units there for the y-axis. And then the x-axis is number of years of use. Notice all the numbers are positive here. So we're kind of just sticking in the first quadrant because we're not talking about negative dollars or negative time. So we're just keeping it positive. All right, but notice the direction of this graph, we are going down. So what we can see is as the years increase, as time goes by, the value of a computer will go down, will decrease. Okay, so we can count rise over run, or we can maybe use the slope formula. That might be better. So let's pick 2 points on the graph. Notice the units on the side here, 0, and then there's the little hash mark, and then 6, and then another mark, and then 12. So it looks like they labeled every 6 units, but the ones in between would therefore be every 3 units. So it looks like we're counting by 3s here. So I'm just going to fill those in. So the point that we have to start here, it looks like that would be 0, 27. That's the y-intercept of our graph. So when 0 years have passed, the value of a certain computer is $27. Nope, that doesn't make sense. $2,700. Okay, makes a little more sense. $2,700. Okay, and then let's pick another point on the graph. The next one that's labeled here after 1 year. So 1, Now the value of the computer is down to $2,100. Okay, so that's enough to plug into a formula. All right, so x1, y1, x2, y2. All right, so m equals y2 minus y1, that would be 2,100 minus 2,700 over, and then x2 minus x1, that would be 1 minus 0. 2,100 minus 2,700 would be negative 600, and then 1 minus 0 is 1. So negative 600 over 1 would be negative 600. So the rate of change, we would call that negative $600 per year. That's one way to describe that. Okay, so the value of the computer is decreasing or going down at a rate of $600 per year. Okay, good. So that's all we have for our official notes. I'm going to pause the video here and just take a minute or two or more to show you a couple of the MyLabs Plus homework examples. So if you'd like to pause now and maybe come back, that's fine. I'm not planning to make a separate video. I'm just going to pause, and then the last chunk of our video right now, we'll take a look at some of the MyLabs Plus homework problems. Okay, so here we are looking at our homework in MyLabs Plus. This is homework number 17 on slope. And we'll just kind of click through and see what we find and see what might be something good to go over. So here's number 1. Graph the line through the points -4, -1, and 0, -5, and find its slope. Use the graphing tool to graph the line. Okay, so this is good practice for graphing. We've done this before, so let's click on our graph. Click on the line tool. I'm going to find -4, -1. So left 4, down 1, clicking there. And then 0, -5, that's 0, and then down 5 on the y-axis, 0, -5. Okay, so there's my line. I've just graphed it. So I'm checking my answer for my graph. Now, let's find the slope. Now this is a multi-part question, so let's read carefully. How to find the slope of the line. Okay, so I have some choices. Choice A says find the ratio of the horizontal change to the vertical change. Choice B says find the ratio of the vertical change to the horizontal change. Oh boy, and then choice C, find the ratio of the difference of one y coordinate and the corresponding x coordinate to the difference of the, yeah, it's not that one. It's something with horizontal and vertical change. Sorry, I'll finish reading C just in case you need to hear it. So here's choice C, which is not going to be the one. Find the ratio of the difference of one y coordinate and the corresponding x coordinate to the difference of the other y coordinate and the corresponding x coordinate. Okay, no. So slope of the line, that's going to be rise over run. And there's a formula for that, of course. So rise over run. Okay, but that's kind of enough to answer this. Rise is the vertical change, up and down, and then run is the horizontal change. So it's choice B here. Find the ratio of the vertical change to the horizontal change. That's why our formula has y's first, so y2 minus y1 over x2 minus x1. All right. Okay. The slope of the line containing 2 points, x1, y1, and x2, y2 is given by m equals, okay, now we get to choose the formula. So all the choices look similar. We're going to read carefully. Looks like it's, on my problem at least, it's this last choice. So just be super careful as you're looking. y2 minus y1 over x2 minus x1 is the correct choice. Okay. Now we're plugging in. Okay, substitute the values of the coordinates into the formula. So they're kind of telling us what to label here. It says let -4, -1 be x1, y1. So x1, y1. And then 0, -5, that'll be x2, y2. All right, so y2 minus y1. So I'm filling in -1 for y1. It's a little fill in the blank problem. All right, and then x2 minus x1, I just cleared it, but x2 was 0. So I'm going to do 0 minus -4. Okay, now we'll simplify. -5 minus -1 is really -5 plus 1, which is -4. So I'm getting -4 over 4. 0 minus -4 is 4. So -4 over 4. Now we simplify. -4 over 4 is equal to -1. Because 4 divided by 4 is 1. Okay, so there you go. So it really makes you work for it with that one. Some of these introductory questions are like that. Another way we could have done it, if we weren't forced through all those parts, is we could pick the 2 points that we had plotted and then just counted rise over run. So down 4 over 4, which is -1. That would have been faster, but that's okay. Good practice using the formula. All right, so now you'll be ready when you get to number 1. It's a multi-part question like that. Okay. Oh, and what did I just do? Oh, I guess I just clicked similar question. Nope, we're not doing it again. Okay. All right, number 2. Find the slope and the y-intercept. So 4x minus 8y equals 36. This is another multi-part question. What is the best first step to find the slope and y-intercept? So our choices are solve the given equation for y or solve the given equation for x. We want to choose solve for y. Okay, now we're going to do that. So we're subtracting 4x on both sides. So 4x minus 8y equals 36. When I subtract 4x on both sides, I get -4x plus 36 on the other side. Okay, now what we're doing is dividing everything by -8. And I'm not a huge fan of how they're showing this. That's okay. Let me back up a little bit. So I'm just rewriting what we already did. -8y equals -4x plus 36. Okay, so what I would have had you do is divide each term individually by -8. What they're having you do is, first of all, it's not in the correct order, which is going to bother me. And they're just having you write -8 in that denominator to start out, which is okay. I just want you to know it's the same thing. Okay, now you're being asked to just simplify in one step. So going back to how I've written it over here, dividing each term separately, that means we can reduce each term separately. Okay, so -4x over -8, that reduces to just +1 over 2x. And then 36 over -8, I can reduce those both by 4. So let's write that out. And instead of keeping it over a negative, I'm just going to change this to a minus. So it's going to just become -9 over 2. So 36 over -8, it's going to stay negative. Reducing by 4, we get 9 over 2. So y equals +1/2 x minus 9/2, or 9 over 2. Okay, good. So now that we have that rearranged, we should be able to identify the slope and the y-intercept. So the next part says for an equation in the form y equals mx plus b, m is the slope and b is the y-coordinate of the y-intercept. So it's just making sure you know what m and b stand for. Therefore, the slope of the equation is, okay, so remember what our equation was. Y equals 1/2 x minus 9 over 2. Okay, so m is 1/2, and then b is that -9 over 2. So our y-intercept is 0, -9 over 2. Okay, so that's what we're preparing to fill in these blanks here. So therefore the slope is 1/2, and the y-intercept is 0, -9 over 2. There it is. Okay, good. All right, so for number 3, choose the word that correctly completes the statement. If m is greater than 0, the graph slants either up or down from left to right. Okay, greater than 0 means positive. So that's what we mean, positive. Positive, we're going up from left to right. So we're going to choose up for that one. Okay. Next question, number 4, if m equals 0, the graph is horizontal. That's that flat line, side to side. Number 4, m is less than 0. That means negative, so we're going down from left to right. Okay. Yes. Okay, number 6. This is kind of a strange question. It's asking us to kind of drag and drop our answers here. So choose the slope of each line that matches each graph below. So we have 3 graphs, and then we have this kind of like word bank, but it's not words, it's number bank. All these different choices in these blue boxes, and we get to drag them where they go. All right, so let's do one graph at a time. The first graph, this A graph here, let's see if we can find the slope. Okay, so I have these 2 points labeled. I think we can do this just by counting rise over run. So my line is going down from left to right. Let's count rise over run. So if I'm going down, it's 1, 2, 3, and then over 2. So it looks like for choice A, we're going down 3 over 2. So that means my slope is negative 3 over 2. Now, if you look in our choices, there's negative 2 over 3. There's positive 3 over 2, but here's our negative 3 over 2. That's the one we want. So I'm going to click on this and then drag it to this A box. Now, this is kind of annoying to do. See how I'm dragging it? Watch how the A box, it needs, if it doesn't get highlighted, it doesn't work. So drag it until you see the box kind of highlight and it kind of lights up or darkens there. Okay, there we go. That's what it should look like once you've dragged it. The number should stay in the box. Okay, now let's do the next one. Choice B, or graph B. All right, so we'll focus on that one now. This one appears to be going up from left to right, so positive. If I count, we're going up 1, 2, 3, 4 over 1. So it looks like for this one, up 4 over 1. M would be 4 over 1, which is just 4. So I'm going to look for positive 4 for that one. So I'm looking in my choices. Here's positive 4, dragging that one into that B box. And then our last graph, labeled graph C. This is a horizontal line, just flat line going from left to right. Up 0 over whatever, up 0 over 1, up 0 over 5. No matter which 2 points we would choose, we would be going up 0 over something. So our slope is 0 for this last one. So I will drag the 0 choice into that C box. All right. Good. Now, when it's showing me, when it's giving me my good job box here, it's really giving quite a bit of detail with, you could plug numbers into the formula for each of these. And we didn't do that. I just counted rise over run, but this would be what your slope formulas would look like if you wanted to do it that way. So that's number 6. Okay. Now we're going to get to more finding slopes of lines from graphs. So number 7, here's another one, counting rise over run. We kind of just did that, so I'm going to skip ahead. Number 8 is a different one. We're given an equation, y equals 5x plus 10. It's in that y equals mx plus b form already. M is the number in front of the x, which is 5. Sometimes students write 5x. That's not correct. M is the coefficient of x, so it's just the number part. The slope is 5, not 5x. And then the y-intercept, that's the b part, would be 10, or we could write it as an ordered pair of 0, 10. But we're just filling in the 10 in that little fill in the blank. Okay. Number 9 might look different. It's f of x equals negative 3x minus 4, but remember, f of x is still just y. So this is really just y equals negative 3x minus 4. And now it's back to just y equals mx plus b. So m, the slope, would be negative 3, and then b, the y-intercept, would be 0, negative 4. Okay, so very similar to the previous question. Okay, number 10 is also similar. It happens to have fractions, but it's still in that slope-intercept form. Okay, so still the same idea. The fractions really don't make it any harder. Okay, here's another function one. G of x equals 4.1x minus 6. 4.1 would be the slope. 0, negative 6 would be your y-intercept. Okay, here's a harder one. Number 12. 7x minus 4y equals 17. Okay, so to find the slope and the y-intercept, we need to get the y by itself first. It's not in slope-intercept form yet. So I'm starting by subtracting 7x on both sides. So negative 4y equals negative 7x plus 17. Divide everything by negative 4. Y equals negative 7 over negative 4 becomes positive 7/4 x, and then 17 over negative 4, just write negative 17 over 4. Don't try to give it decimal. I can see in the instructions, type an integer or a fraction. Just keep things as fractions. If they don't simplify, then just write it as it is. So the slope would be 7/4. And then the y-intercept is 0, comma, and I'm going to write negative 17/4. And that, fill in the blank. So that one was harder because we had to solve for y first. Number 13 is similar, so I'm going to skip it for now. Ooh, number 14. A little extra tricky with a fraction next to the y. All right, let's figure this one out. So this is 2 minus 1/2 y equals 4x. Before I show you, let me view the example because there's a few approaches we could take and I want to see what they're showing. Okay, yeah, eventually they're going to have you cancel out the fraction by multiplying by the reciprocal. Okay, so that will be fine. All right, so here's our equation. 2 minus 1/2 y equals 4x. So to get the y by itself, let's start by subtracting 2 on both sides. So then we'd have negative 1/2 y equals 4x minus 2, because we subtracted the 2. Now to cancel out this negative 1/2, essentially we need to divide by negative 1/2, but look how terrible that would look. So instead of dividing by negative 1/2, we should know that the same thing, you know, when you divide by a fraction, you're actually just multiplying by the reciprocal. So we're multiplying everything by negative 2 over 1. Okay, so in other words, remember keep, change, flip, right? So to divide by negative 1/2, that's the same thing as multiplying by negative 2 over 1. And by the way, negative 2 over 1 is just negative 2. So it's all going to work out pretty nicely here. All right, so to get y by itself, that's what we did. Negative 2 over 1 times negative 1 over 2 just cancels. Negative 2 times 4x is now negative 8x. Negative 2 times negative 2 is now positive 4. So y equals negative 8x plus 4. So the slope would be negative 8. The y-intercept would be 0, 4. Okay. Okay, number 15 looks a little bit longer, but it's the same idea, solving for y, getting the y by itself. Actually, I can see this one being a little different, so I will do this one. 6y plus 4x plus 9 equals 12 plus 4x. Let's subtract that 4x first on both sides, and what happens is all the x's cancel out. So we're left with 6y plus 9 equals 12. If we subtract 9 on both sides, 6y equals 3. Then divide by 6. Y equals 3 over 6, which is just 1/2. So when you have y equal to a number, that's just a horizontal line. Okay, so there's no x here. It's kind of like y equals 0x plus 1/2. That's another way to see it. So the slope is actually 0 for this one. It's kind of a unexpected answer here. So the slope is 0. the y-intercept is 0, 1/2. So that b term is 1/2. Okay, and looks like we're back to finding slope from a graph. Number 16, finding slope from a graph. Number 17, finding slope from a graph. This would be counting rise over run. Number 18, finding the slope from the formula. So you're given 2 points, 8, 40, and 2, 4. We've done that before in our notes, plugging into the formula. So I'm going to kind of skip ahead on some of these. One of them involves decimals. Let's see, number 20. The points are negative 8.1, 15.6, and negative 7.1, 1.3. Okay, x1, y1, x2, y2. It does say type an integer or a fraction, so I just want to see how that will work out. So y2 minus y1 would be 1.3 minus 15.6 over, and then x2 minus x1, negative 7.1 minus negative 8.1. Okay, 1.3 minus 15.6 is negative 14.3 over, and then negative 7.1 minus negative 8.1 is 1. So we're getting negative 14.3 over 1, which is just negative 14.3. Okay, I'm just going to test out whether this answer will be accepted. I have a feeling it won't be because this is not an integer or a fraction, it's a decimal. Let's just give it a try. So I'm typing negative 14.3. Okay, yeah, it doesn't like it. Okay, so here's what you can do, a little trick. We want this to not be a decimal, so what we really want is to move the decimal over. So I'm going to go back over to the previous step when we were over 1. When we move decimals over, it's really like we're multiplying by 10. So if you just multiply by 10 over 10, we end up getting negative 143 over 10. And that's, I think, going to be our accepted answer because it's a fraction rather than a decimal. Yeah, okay. Yeah, a little tricky, that one. Okay, ooh, here's the treadmill one. We know how to do that because we did that in the notes. Oh, here's the pitch of a roof. Okay, so rise over run again. Looks like our rise would be 0.9 feet here. That's the up and down part, 0.9 over. And then the run, that's the side to side part, 6.9. Okay, now we're being asked to round to the nearest percent. So that tells me we're probably going to get a decimal that's not so nice. So I'm using my calculator, 0.9 divided by 6.9. I'm getting a really long decimal, 0.13043478. Okay, I don't need all those digits, but I'm going to keep them for now. To change that decimal into a percent, I would move the decimal twice to the right. So that would be 13.04%. The nearest percent is kind of like the nearest whole number here. So I'm just going to write 13% for my answer. That would be the nearest percent. Okay, good. Okay, and then we have a rate of change graph. We've seen that before. Let's see, we can count rise over run, although I don't really trust us to do that. Let's use the formula instead. We have these 2 points, 2010 and then 8.4, 2015 and 27.1. So we could do the y coordinates, 27.1 minus 8.4, that's the rise over, and then 2017 minus 2010. Okay, so on the bottom we have year. That's our kind of our units for the x-axis, and then the y-axis, it says luxury purchases in billions. But notice it does ask for the answer in billions per year anyway. Okay, so 27.1 minus 8.4 is 18.7. 2017 minus 2010, that would be 7. So 18.7 divided by 7. It's a long decimal, I'm going to have to round. 2.6714. It says to round to 2 decimal places, so that would be 2.67. So it looks like, what is this graph saying? Going up. It's going up at a rate of $2.67 billion per year in luxury purchases. Okay, here's the rate of change one that we did in the notes with the value of the computer decreasing. So you've seen that already. And then there's one more rate of change, number 25. Okay, so I'm going to end here. Hopefully that's more than enough examples on lesson 17 for slope. All right, let's see, I think only 2 more to go after this. We have lesson 18 and lesson 19 to go. All right, thank you.